Hello. Today we're going to take a look at completing the square. Now, completing the square can be a pretty difficult topic to cover. However, it is crucial in helping us figure out or even deriving the quadratic formula. So we're going to take our time to go through the steps that are required, and as long as you can follow those steps, it shouldn't be too difficult by the end. So first off, one big piece of completing the square is taking a look at things and factoring them. So remember, when we have perfect square trinomials, we can factor them down into square binomials. So just for an example, let's say we had x squared plus 2x plus 1. We can factor that down into x plus 1 squared. Or vice versa with that second example where we have something to do with a negative. So we could also do x squared minus 2x plus 1, and that would be x minus 1 squared. Now our square root property, I know it's written out pretty confusing. However, essentially what this is saying is that if we have, let's say, x squared is equal to 7. Now, if I take the square root of both sides, really I get two answers. I get a positive and a negative version of this answer. So I would have x is equal to negative root 7, and I would have x is equal to root 7. And the reason why is because negative root 7 squared would give us 7, along with positive root 7 squared. So because both of those would give me an answer of positive 7, those will both be okay answers for us. Now, this next little piece, we're going to take a look at solving, which will be kind of the end step if we are dealing with completing the square. So for this first one, all we have to do on that left-hand side, we should recognize that that's a perfect square trinomial. So we would have x minus 5 squared is equal to 9. Now my steps in getting x by itself would be taking a square root, and remember that property that I just told you guys. So we will have x minus 5 is equal to plus or minus the square root of 9, which will be 3. And then our last step would be adding 5 to both sides. So that we would have x is equal to 5 plus 3, which equals 8, and x is equal to 5 minus 3, which will give us 2. So those are your two answers for this one. All right, now if we take a look at this other one over here, we're going to essentially do the same thing. We want to take that x squared plus 24x plus 144 and factor it down into that binomial. So that'll end up being x plus 12 squared is equal to 5. Now, from here, we'll square root both sides. X plus 12 equals, remember, plus or minus root 5. Since root 5 is an irrational number, you will just leave that with the radical over it. And then our last step will be to subtract 12 from both sides. So our answer can look simply just like this. Negative 12 plus or minus the square root of 5. It is perfectly acceptable in my book. Okay, now if we are actually completing the square, we want our equation to be in the form of x squared plus bx. That is the most important kind of piece. So notice there's no coefficient in front of the squared term. So we're always assuming that that would be a 1 out front. If there is a number out front, we would have to deal with it. We'll see an example of that at the end. So some quadratic equations cannot be solved by factoring, like those ones that we just did. In these cases, the method of completing the square can be used. Completing the square, a term can be added. In completing a square, a term can be added to the quadratic expression x squared plus bx to form a perfect square trinomial. So that is the goal in this. I'm not really going to spend too much time into the notation and everything like that, but you can see in that box below that everything is based on that b term. So you're going to take that, cut it in half, and square it is essentially the most important piece to realize. Now this is just a little bit of practice doing completing the square. This isn't in a solve type of manner. So we're going to do just exactly that. We have x squared plus 18x, where 18 is equal to that b term. So if I'm going to complete the square, I need to take that 18 and I'm going to divide it by 2 and I'm going to square it. So what that does is that tells me that I have 9 squared. So if you think about the importance of 9 compared to 18 when we're thinking of a perfect square trinomial. So 9 squared equals 81. Now, if I was going to factor this down, remember the key to factoring things down, if you're in my class, is what multiplies to this number but adds up to get that middle number. Okay, that's if you have a perfect square trinomial, or as long as your x squared term has a 1 in front of it. This works pretty well. Now, 9 times 9 is 81, 9 plus 9 is 18. So that's the reason why we end up doing this stuff down here, is the way that our numbers will relate to one another. So that b divided by 2, or that in this case the 18 divided by 2, that's just 9 plus 9. What two numbers add up to get 18? Well, 9 and 9. What two numbers multiply to get 81? Well, 9 and 9. So we would rewrite this, if we were completing the square, as x plus 9 squared. And then we would go on from there. But like I said, this is just a quick example to get us thinking into the completing the square method. I'm going to give you a couple extra problems along with this one. So you might notice we have more than that b. We have more than x squared plus or minus b squared. We have this negative 8. So I'm going to take that negative 8. I'm going to add it to both sides. Now when I do that, I'm going to rewrite this as x squared minus 14x. I'm going to leave myself a little bit of room because I know I'm going to be adding in that c term. And that's going to be equal to, not plus, equals 8 on the other side. Now we need to complete the square. So I'm going to take b, in this case it's negative 14. One thing about that negative, since we're squaring it, it doesn't really matter if you include that in your completing the square process or not. But that's going to be negative 7 squared, which will be 49. Okay, so I'm going to do plus 49 to both sides. Now I can continue to solve my problem. This x squared minus 14x plus 49, that can be rewritten as, let's move this down here, x minus 7 squared, and that's going to be equal to 57. Now I will square root both sides. Remember, I get a plus or a minus. Now I have x minus 7 is equal to plus or minus root 57. Now 57 is not a prime number, however the numbers that go with it are. So we will just keep that as root 57. add 7 to both sides, so we get x is equal to 7 plus or minus root 57. Now I want to give you an example. Let's just say we have x squared plus 5x, and I'll set it up to myself or for myself nicely. We'll just say equals 8 over here. Now, what's different about this is if you have an odd number in the middle there, when I cut it in half, I wouldn't get a nice number. So I would leave that as 5 over 2, and then I have to square that. So 5 over 2 squared is going to give me 25 over 4. So I need to add 25 over 4, because whatever you do to one side, you have to do to the other. And then I would actually probably want to rewrite that 8 as 32 over 4. So our left-hand side, what this ends up being is you can take that number that's in your parentheses and you can, like, this is the number that when you break down completing the square into that binomial, that's the number that you end up using if you hadn't noticed that earlier. So we will have x plus 5 halves squared is equal to 32 plus 25 gives me 57 again. Interesting. So 57 over 4. Now on both sides here, I need to square root. I'm going to get rid of that green because that's a little bright. So we have x plus 5 halves is equal to, don't forget your plus or minus, square root of 57 over 2. Okay, now I would subtract 5 halves from both sides. Don't be afraid of fractions. They do not bite. So x is equal to negative 5 plus or minus square root of 57 all over 2, because those denominators are the same. So that's what our answer would look like in this case. We got one more here, and this one's pretty ready. Let's do our last problem here. So we have, during a baseball game, a player hits a fly ball. The height f of t in feet of the ball at time t in seconds can be described by the function f of t is equal to negative 16t squared plus 64t plus 4. Write the equation in vertex form by completing the square. So remember, your vertex form is y equals, you might have an a out front, x minus h, that would be a horizontal shift, squared, plus k is a vertical shift. So this is kind of a tricky problem because it's like we're doing completing the square inside of a problem to get that h, or x minus h squared piece. So if I'm looking at our function that they give us here, I need to only deal with this piece, and out of there I need x squared, or in this case t squared, so I need to factor out a negative 16. So we're going to have f of t is equal to negative 16 t squared minus 4t, and then we're still going to have that plus 4 on the outside. So we can complete the square with that t squared minus 4t piece in there. So we're going to take that b term, cut it in half, that'd be 2, square it, we're back to 4. Now this part is the tricky piece, so we'll have negative 16 out front, t squared minus 4t plus 4. Now we added 4 to the inside. Now because we had factored out a negative 16, we're going to multiply that 4 by a 16 and add it to the outside. So we have this plus 4 that we had before, and now off of our completing the square, we're going to add 64. Give myself a little more room. So that means our problem right now looks like negative 16. I can factor that piece down to t minus 2 squared, plus 68. And that is what our problem would look like. So we would have a negative or an upside down parabola that would have a y-intercept of 68. So this would be our final solution there. Thank you guys for watching. I hope you gained something out of this. Hopefully completing the squares a little bit easier for you.